Welcome to this explainer. Today we're diving into a massive pivot happening over at OpenAI. We're talking sudden government pressure, a brand new custom silicon chip, and how these two forces are completely reshaping the future of frontier AI.
Here is our agenda for today. 1. A highly restricted launch. 2. Meet the GPT 5.6 family. 3. The dual-use security dilemma. 4. The inference cost problem. 5. Enter OpenAI's Jalapeno chip. And 6. The ultimate AI feedback loop.
Kicking things off with Section 1, a highly restricted launch, not your average software drop.
So OpenAI just dropped GPT 5.6. But this wasn't your typical release where every developer rushes the API all at once. According to Axios, the US government actually stepped in and asked OpenAI to limit this initial launch to roughly 20 partner companies. Just 20. That is a massive departure from standard launch protocols. The big takeaway for us here? Washington is fundamentally treating this advanced AI as a strategic technology now, something that literally requires a government review before the broader public gets their hands on it.
And this isn't happening in a vacuum. This restricted access really echoes the recent regulatory actions we saw against Anthropic's models. It's got experts impartially questioning, is this a new, unofficial regulatory norm taking shape in Washington? Could this delay future product launches across the board? Dean Ball, a former White House AI advisor, hit the nail on the head, describing this environment as a, quote, de facto involuntary licensing regime. It's a fascinating shift, and it makes you wonder if closed-door negotiations are just going to be the new normal before any major model hits the market.
Moving right along to Section 2. Meet the GPT 5.6 family, Sol, Terra, and Luna.
Let's look at the models themselves to see what exactly the government is so eager to monitor. OpenAI is bringing a new three-tier lineup to the table. The flagship model is Sol, which brings some major gains to agentic workflows. That one comes in at $5 per million input tokens and $30 for output. Then we've got Terra, serving as your balanced mid-tier everyday model. And finally Luna, which is built to handle those high-volume, lower-cost tasks for highly scalable workloads.
But let's focus on the raw capability of Sol for a second, because, wow. It introduces a max reasoning mode for much deeper thinking, plus an ultra mode specifically designed to coordinate multiple subagents. It's an absolute beast for technical work. I mean, it set a brand new state-of-the-art score on Terminal Bench 2.1. It actually even beats Anthropic's Claude Mythos 5 on coding workflows using just a third of the output tokens. But managing all those coordinated subagents? Yeah, that makes it incredibly token-hungry.
Which brings us to Section 3, the dual-use security dilemma. Balancing defense and offense.
The immense capability of a model like Sol creates a really tough dilemma. Think about it. The same tools that help find biology or cybersecurity vulnerabilities can theoretically be used to exploit them. This highlights a major divergence in how AI companies are actually handling safety right now. On the one hand, you had Anthropic's controversial approach with Fable 5, which invisibly down-routed risky prompts to older, less capable models, which ended up causing a ton of frustrating false positives. OpenAI, on the other hand, took a radically different path. They built refusal behaviors directly into GPT 5.6's core to effectively handle those sensitive cyber and biology requests. They're tackling the issue head-on, instead of just handing the user off to a downgraded experience.
And to back up that safety architecture, OpenAI spent a staggering 700,000 A100 equivalent GPU hours on automated red teaming and testing. To put that into perspective, that is an enormous amount of compute dedicated purely to safety. The whole goal was to make absolutely sure Sol can effectively assist cyber defenders in finding bugs without autonomously chaining exploits together to act like an attacker.
Next up is Section 4, the inference cost problem, the price of intelligence.
Running these complex, multi-agent workflows securely across millions of users creates a massive financial bottleneck for the company. Because the real expense isn't just training the model anymore, we really have to talk about inference. That is the computational work and cost of running the model every single time someone uses a tool like ChatGPT or the API. And inference gets exponentially more expensive as these new AI agents constantly plan, call tools, check results, and revise code. Literally every single time a user asks a complex question, the meter is running.
To combat these soaring costs, the entire industry is pivoting hard. Just look at the projections. Custom ASIC shipments, meaning chips designed for various specific workloads, are projected to grow by 44.6% in 2026. Compare that to just 16.1% for standard GPUs. The whole industry is waking up to the fact that relying solely on general-purpose hardware for inference is just way too expensive.
That leads us perfectly into Section 5. Enter OpenAI's Jalapeno chip, custom silicon by Broadcom.
To directly solve this inference problem, OpenAI unveiled its first major move into custom silicon on June 24th, the Jalapeno chip. The strategy here is highly specific. Built in partnership with Broadcom and manufactured by Celestica, the Jalapeno chip is designed exclusively for inference workloads, not for training models. This is all about serving users as efficiently as possible. And early testing suggests Jalapeno could cut OpenAI's inference costs by roughly 50% compared to standard AI GPUs. A 50% cut, that is an absolute game changer for their bottom line.
The development cycle for this thing was blindingly fast, too. They went from initial design to manufacturing tape-out in just 9 months. That's reportedly the fastest development cycle ever for a high-performance ASIC. From there, we're looking at small-scale prototype deployment in late 2026, ramping up significantly through 2027. And the ultimate target? A massive, gigawatt-scale full deployment by the first half of 2028.
Finally, we arrive at Section 6, the ultimate AI feedback loop. AI building AI. This isn't just about hardware. We're looking at a profound new paradigm. You might be wondering, how did they achieve that blistering 9-month development timeline? Well, OpenAI actually used its own advanced AI models to optimize parts of the Jalapeno chip's design. This creates this incredible ultimate feedback loop. AI models help design better, cheaper inference hardware. That cheaper hardware dramatically lowers the cost of running the models. And then, those savings are pumped directly back into funding more compute and even smarter AI models. It's literally an engine of acceleration.
This bold move puts OpenAI squarely in the exact same arena as the biggest tech titans on the planet. I mean, Google is already on its 7th generation of TPUs, Amazon has deployed over 1 million Trainium processors, Microsoft is rolling out its Maya 200 accelerators, and Meta has its MTIA chips. Now, OpenAI joins the ranks with Jalapeno. They are all aggressively building their own custom silicon to control their own destinies and completely sidestep any supply bottlenecks.
OpenAI is already confirming they're considering expanding their custom chip work from inference into training in the future, which leaves us with a pretty critical question to consider as we wrap up this explainer. As AI models like Solemn become increasingly capable, increasingly regulated, and massively powerful, what exactly happens to the industry when a single company controls the entire stack? From the most advanced agentic software right down to the custom silicon it runs on. It's definitely something to think about.